Hey yo. So right now we will have Philipp. Um, Philipp is developer or advocate from right now he's from Elastic, right? Working in Elastic. You may know this company for Elastic Stack, such software pieces as Elastic Storage, Kibana, Beats, Logstash. He's based in Vienna, constantly traveling in Europe, and beyond to speak and discuss open source software, search, databases, infrastructure, and security. Actually, please welcome Philipp Krenn.
Hi everyone. Let's see where we can take this. So thanks for the introduction. Yes, that's me. I mostly travel around to talk about the nice stuff that we do. That's kind of the idea of my job. So I'm coming to Kiev quite frequently, like I think 4 or 5 times a year. So let's talk about testing. Probably the first phase of testing is it compiled. We don't need tests. It's fine. It will work out somehow. And later on, you probably say, like, maybe we need some tests. And then you say, oh, the unit tests are working and everything is good. Let's start off just from the unit tests. And at some later point, maybe you decide that, well, maybe unit tests are not everything. Because sometimes unit tests are nice in isolation, but like the overall system might not be behaving correctly, which might look something like this, where you have a note which says, like, don't turn off this switch because it will also turn off the elevator, which is kind of like the unit tests have probably passed, but the integration test of the entire system didn't work out so well. Or maybe you've seen this one. It's kind of, yeah, the unit tests are kind of working, but maybe not entirely. You can also see the unit test is passing. The other unit test is passing as well. But the entire system is maybe not working correctly. Or this one where, yeah, the unit test works, but it's also not really the perfect behavior. Or where you see, yeah, it's like all the independent pieces, they are working, but it's not really the point of this. Or my favorite example is this one. You can see the unit tests are working, but this is probably still not the way it should behave. So let's all agree that you want more than unit tests. You want to have like some kind of integration tests which put together stuff on a higher perspective. If you disagree with that, we can discuss that afterwards, but let's just say like we want to have something that tests a bit more than just units of your software. And then you come to integration tests, and then you start doing integration tests. So the first thing you might be doing are then mocks. Who is using mocks to kind of simulate something or build something or build an assumption on which you can base your integration tests? So if you're coming from the Java world, these are some common examples of what to do or how to do that, but it doesn't really matter. There are mock frameworks for pretty much any programming language, and it's just like building up some precondition or working on some other piece of software you have implemented to make your integration tests work better or quicker or easier. And unfortunately, this Pippi Longstockings, this only works in German, which is my native language, but the song, I don't know if you remember the song from Pippi Longstockings, is the direct translation from German would pretty much be like, I mock the world the way I need it, which is oftentimes what I see, that people write mock integrations, but the mock integration is not really what the real system behaves like. It's more or less what they assume or want the system to behave. Also, the thing with mocks is oftentimes like, it's more or less the happy flow. So you can see, you're starting off, you make the perfect loop, you evade all the problems, you just walk on your mock data over all the pits that you have in your software, and then this is your mock data, and these are your actual users. So sometimes this is just, mocking is fine to get you somewhere, but it might not show you reality, or it might not get you all the way to where you want to go. So it's nice if you have tests that you want to be, or behave quickly. And it's also nice to mock something that is not under your control. For example, if you need to test against an external API of a third-party provider, let's assume you have a REST API of somebody and you want to test the integration into that, you probably don't always want to actually use their API, either because if that API is down, your test will suddenly break and you don't want it, or maybe the provider of that API is also not that happy if you constantly test against it and add load or send weird messages over their system. So for external systems, a mock might make sense because it's just quicker and under your control and you don't cause problems to others. But, for example, if you want to test data stores, they are normally under your control and you want to test the real thing. You want to see like how are they behaving performance-wise, how are they behaving like their actual behavior, how do they break when you upgrade them. So that will only be possible if you check against the real system. So the first thing you could then do is you could use one of the, I always call them the in-memory cousins. So for example, in again, the Java world, there are these in-memory implementations of relational databases. So rather than testing against MySQL, Postgres, Oracle, SQL Server, whatever you have, you just use one of them because they're kind of close. They're not really the same, but they're kind of close. So it's always a bit of the question, it's like the same, but different, but still kind of the same. The question is that kind of the same enough to make it properly work for your scenario? Because sometimes it's not. Sometimes they have very weird constraints, how they behave, for example, around nulls, or their referential integrity is not really behaving like the original system that you want to test. And the final problem is sometimes you just don't have the embedded version or in-memory version of a data store to test against. So for example, for Elasticsearch, which I'm using quite a lot, we used to have a version that you could embed in Java. Since Elasticsearch is also written in Java, you could just embed the jar and then run it as part of your tests. But we stopped doing that, or we stopped supporting that embedded version. Can anybody guess why? So one of the reasons is, for example, people started to use that in production. And it was never intended for production. And then terrible things would happen, and people would lose their data, and then they would come complaining to us. And we were like, yeah, we don't really want this to happen. Like, it's not great if you run this in an embedded fashion for any production system. It's just not supposed to happen like that. Also, we did a lot of code changes internally, and we enforce a Java security manager internally, and that leads to various problems. Also, we have a lot of dependencies in Elasticsearch, and then they might collide with the dependencies in your project. So for example, you might have multiple implementations of the same logger, and then you need to, in a complicated fashion, include and exclude specific imports to avoid collisions in your class path. So nobody really wanted that. That's why we stopped supporting that embedded version. So the good thing about an embedded version or the in-memory version is oftentimes it's kind of good enough to make it work, but it's still not the real system, and oftentimes you don't really have that in-memory implementation that you want to use. Like for Elasticsearch, you just don't have that. So what do you do instead? The next step could be you use the actual data store. So you just run your integration tests against the version of the software that you really want to use. So you have a local installation, you have a Docker container, or you run it in the cloud. Any of these three options will work. And I would call them like the good old approach, because this is what everybody knows. You just run the installation locally, or you run a Docker container, or just have a cloud UI, or a cloud interface you use. So you don't have to change anything to the normal behavior in your application. So let's take a quick look at that. So I have some code of what we're doing, and this is really just like a hello world application of testing. So I have a parent test class, and what the parent test class is doing basically is, at first I'm trying to remove an index which shouldn't be there, so it should fail if there is any data that I'm not expecting. Then I'm creating a new index. So an index is basically the thing where you just store your data. I'm creating a new index, which I call the Elasticsearch index. It has some test index, is the actual name, I think. So I create that. I store one document into it, which has the name or the attribute's name with the value Philipp. This is the simplest document you could store, and that's what I'm storing in here. I'm writing that out, And at the end, I make sure like there is exactly one index, and that one index is the index name that I'm expecting here. And I count that there is exactly one document in that index. And I check, does it have the right ID from the one I've just written above. And at the end, I just clean up. So it's really a super simple use case. It's just like write one document into Elasticsearch and make sure that one document is there. It's not doing anything fancy, but it will be enough to actually test the integration layer of our data stores later on. So let's see how to actually run this. So I have various tests, and all of them are using this parent test, basically. So trying to use the actual data store, I'm just saying like, hey, either use the system properties, so you could set an environment variable for this, or just use the defaults. So you can see I'm connecting to Elasticsearch on localhost on port 9200. Those are all the default values. So I just expect something to be running here. I create a new client. So here I'm creating a new client to connect to all the configuration parameters that I've configured above. And then I'm just making sure, hey, I could run or create that client, or no, it failed, I couldn't create one. And at the very end, I'm closing that connection again. And then I can just run the test, and what will happen? Let's see what will happen. It fails. It fails with connection refused. Why? Any guesses why I run into a connection refused? Yes, exactly. Nothing is listening. And that's exactly the problem with that approach, that you suddenly have this dependency on an external system. It's not just in your tests. You always need to make sure that the data store that you're testing is actually there and installed. Because it's not part of your program, you have this external thing you need to manage. And we could totally run that, so I'll just use Docker Compose. So you can see I'm using the current version of Elasticsearch. I'm just giving it some heap memory, make some other small settings, say where this data should be stored here, and then I'm just running that instance. So let's quickly bring that up. And let's start with up and not down. So this is kind of the first problem that you have. Like suddenly you have this external dependency in your tests. You always need to make sure that system is there. And also, whenever you upgrade the version, you will need to make sure that everybody upgrades the version on their local system that they have installed. Because while I have the dependency and the version in, I have that in here, so you can see I have defined my Elasticsearch version here inside my program. You will always need to make sure you have the same version in your external version of the service to actually test against that. And while I'm talking, this should come up, and somewhere, while this is very large, it's a bit hard to see. Somewhere you can see here, it published to this address, and this is the default, like it's listening on all local interfaces on port 9200, which is the default, and this is where I'm trying to talk to it. So now, when I run the test, should this work now? Yes, no, maybe? Hopefully, yeah, maybe. Hopefully it does, otherwise my demo is broken, but it should now work. And you can see, I started a connection on the localhost 9200, which is the default. I saw that I'm connecting to a cluster in version 6.7. I'm trying to remove an old index which doesn't exist. Fine. I'm creating a new index. I'm indexing my one document. Then I'm saying, OK, I found my document, and it has the expected ID. And at the end, I just close the connection again. And well, this is pretty fast because it's not doing much, because also we are managing Elasticsearch externally. And you can see here, at the very end, I've cleaned up and deleted my index, so nothing is there anymore. And we can actually kill this one again. So let's just clean it out, and it's done. So the nice thing is, this is really like the good old approach. You don't need to change anything in your architecture, but it's also this external dependency. It always has to run, and you need to manually make sure that you have the right version of it running to actually test the right thing. And if you're lots of people on your team, everybody needs to make sure they have the right version of this running and not an old version. Otherwise, you're probably not testing the right thing. but it's kind of familiar territory, so that works okay-ish. Yeah. The other thing is parallelization is a bit hard. How could you run multiple tests in parallel with this? Because you only have one instance that every test is sharing. What's one approach that you could use if you want to run lots of tests in parallel? You could randomize the index name, for example. So every test is writing a random index name, so they don't overlap each other. Otherwise, if you always use the same index name and you parallelize your tests, they might still overwrite bits and pieces in your tests and they might randomly fail. So you might want to randomize the index name for that. Okay, next up, you could still try to run Elasticsearch embedded. It's not supported by us, but somebody else made an implementation for that. So there is from Allegro, they're I think the biggest e-commerce site from Poland. They have a project called Embedded Elasticsearch, which just does that. So what it basically does is it figures out what operating system you have. It will go out, download the right binary to the temporary folder, start up Elasticsearch, and run the test, and at the end, throw it away again. So basically, you can programmatically, from within your testing code, start an Elasticsearch instance, and at the end, throw it away again. You don't need to run anything externally anymore, but you can just run that from within your code. So let's see how that actually looks like. So here, we have embedded Elasticsearch. We are making some settings where I want to run this, and kind of the important part is you have now an embedded Elasticsearch object where you can say, I just want to construct an Elasticsearch instance with a specific version here. I'm adding some settings. I set a timeout, like it should start within 60 seconds. And then at the end, after configuring it, I just start my Elasticsearch instance from within my tests. After that, I can actually do the client connection that is the same as before. And at the end, I close both my client and I also shut down Elasticsearch again. So everything is triggered from within my tests, and you don't have any external dependencies. And the other nice thing is I'm using a little trick here to get the version right. So if I see it here, we have a property here, the Elasticsearch version property, and I'm just reading out the version. And this version basically links to the version I have defined in my project. So I'm not hard coding the version of Elasticsearch anymore in my tests. I'm just using, so what I'm doing here is I have this version property, which I basically fill when I build the project, and this here references my definition of this one here. So basically, I define my Elasticsearch version once, and my code uses that version that I have defined in my program code to start exactly that version and bring up a node of that version so I don't have any external dependencies and the versions are always in sync. So you have that, and that's working out quite nicely. So let's run the test. Will this work? No, this one should work, hopefully. However, it will take a little longer because, well, Elasticsearch is a Java process, and it takes about 20 seconds or so on my machine to bring up the Elasticsearch node. So I'll probably need to keep talking, and hopefully everything works out, because in 20 seconds or so, this will continue. But right now, it's in the starting phase, and you can see, start an embedded instance with this specific version. And once enough time has passed, luckily it works now, you can see it just takes a little while until the node is up. So here we have started our Elasticsearch instance. We connected to it, we ran through our tests, and at the end we shut everything down again. So this works nicely, but it takes a little while to get up the process every now and then. You could, by the way, define your own lifecycle, how often you want to start one Elasticsearch instance. So you could either start one instance for all your tests, or you could start one instance for every class, or even for every method. It will be very slow, but you could define the lifecycle of how many instances are you actually starting here. That's fully under your control. Another nice feature is that you can easily customize the mapping is like the schema in a relational database, and you can even install plugins, for example. So for example, since they are from Poland, and Polish is a very complicated language. We don't have the full analyzer for full text search included in Elasticsearch by default. That would be Stempel, the one that you have. For example, Ukrainian has also an external analyzer. You would need to add that plugin. That's very easy with that approach where you just add that when you start it up. And then I create an index where I basically put a specific mapping and basically prepare my index for the tests that I want to run here. So that's nicely integrated, that works. It works from your IDE. You can run as many or as few instances as you want. You can have a custom lifecycle and you can customize it, but you need this custom integration. So what you have here is, you can see you need this embedded Elasticsearch dependency and in a specific version. Generally they don't break, but they might break in major versions. But as if Allegro stops maintaining that embedded Elasticsearch, you will not be able to run this anymore. So you basically have an external dependency added, just for your tests, but maybe something you don't want to do. Just something you need to consider. If you want to have more embedded data stores, for example, there is an organization called Flapdoodle. They have a couple of embedded processes. So for example, they have a template, which is this embedded process generic project, and you can run Redis, MongoDB, MySQL, I think even Kafka. You can run that embedded. It's just like from within your Java process, you start, like they download the right binary, start up the process, you run your tests, and then in your application, you just shut them down again. So that's there and working nicely. The next thing you can do is you can use a build tool to actually start the tests and prepare the system for that. What are the build tools I might be using since I'm using Java? Maven, Gradle. Which one might it be? And no, not and. No. Yeah, so I've already shown you the XML, so this was clearly Maven. So there is a plugin called the Docker Maven plugin, which can talk or work around with Docker images very nicely. It can both build them, but you can also use Docker images for testing and set everything up the way you need it. This comes in very handy afterwards. So what you can do is you can basically run a container. You can basically start a container and stop a container from within Maven. And let's see how that looks like. So what I have is, this is my Maven test. Here, I don't do much. Like I again define where I want to connect to, and then I just set up my client. I don't set up a server in my Java program, and I also don't shut anything down. All I'm doing is I'm starting my client, and I'm shutting down my client. All the logic or all the hard work is actually done in the POM file. So this is for the people who like Maven and who like writing XML. If that's you, that's kind of a nice approach. So what you do is you basically add this plugin here, so the Docker Maven plugin, and what you then say is, I want to use this image here, so the Elasticsearch image. I want to start it up on the port that I've defined. I'm waiting until something replies with a 200, then Elasticsearch has started up with a 60-second timeout. And at the end, you stop it again. So you just start and stop the Docker image that I have defined up here. So this is all you do. So from within your XML, you define what to start up and what to stop. If I run my tests here, will this work or will this not work? Yeah, so the thing is, I need this custom Maven lifecycle, which was this one here. I need to run this Docker start and Docker stop, and by default, that is not being run. So when I run that from my development environment, it doesn't run these phases, so it doesn't start it up. So what you need to do is, you will need to, this is the one I want, you need to say, you run it like this. So you run Maven, Docker start, run your tests, and then Docker stop again to actually start up my image and then run my tests against that and then throw it away again. So here you can see this is the image that we're using. You can see it's 6.7 again. This version, by the way, again, comes from my dependencies, so I don't have an external version defined. It's just being reused from within my program. Now we're waiting for 20 seconds or so until I get 200 back from localhost. So we'll be waiting for 20 seconds or whatever it takes again. And then my tests will run through, and then it will be shut down again at the very end. So we see that in a moment. You can see now that the Maven start has finished. We can run our tests. At the end, we run the Maven stop. Here you can see this is where we stopped and removed the container again. So this worked fine, but you cannot run it from your IDE anymore because we don't have the right life cycles in there. By the way, what happens if I do this? Like, I forget the Docker stop. No, it shouldn't be, because yeah, the next time it will happen, yes. The next time the port will already be in use because we're not properly cleaning up. This is also a not so nice side effect. There is another plugin which can make sure you run through specific life cycles in Maven, the Maven failsafe plugin. That can help you clean up, but right now, in the simplest setup which I'm using here, this will work the first time, but it will leave behind that, yeah, lonely container. So my tests are running. My tests should be passing. But you can see there is no cleanup phase anymore. And if you do a Docker PSA, you can see my 6.7 container has been up for 41 seconds, and it just keeps running. So we'll just kill that. And it stopped, and then we can do a Docker RM. And now we should be clean again. And now you can run your tests again. But this shows you need to be kind of careful to actually clean up properly after your tests. Otherwise, running them once is fine, but running them a second time will fail in a not so great fashion. So that's not so helpful. The way around that would be there is a Maven failsafe plugin which can make sure you can run through specific phases. But if you haven't configured that correctly, you can run into the problem that something stays behind. So it's nice because you can use any standard or customized Docker image. The main downside is it doesn't tie into your IDE, and you can only start a single instance for all your tests, because you cannot say like, oh, start a new instance for these tests or anything. It's just like with Maven, you have one phase before the tests and one phase after the tests, and that is when you can start up and stop the instance. But you cannot start more instances or restart them or clean them out easily. You don't have that control. Okay, and then there are test containers. Test containers are like a more structured approach to tie containers into your Java program to run them in a structured fashion. So there is a generic approach which looks something like this. Here, for example, you would see this is just from within your Java code. In your test class, you can say, for my class, I want to start one Redis container. And I want to run Redis in version 3.02. And it should expose something on the default port that Redis is running on. So this will just start a Redis instance. And that one will also make sure it cleans up at the end. You could also run Docker Compose. So I can reuse the Docker Compose file from the very first example that I've shown you. I just say I'm using the Docker Compose file, and I will start one Elasticsearch instance, for example, and I will wait for it to become available on the default port, and I wait for a 200 to come back to actually work with that. So let's look into that. So what do we have for this one? So here you have a new Docker Compose container where we basically reference our Docker Compose file. And we just make sure we start up this Docker Compose container, and then we wait until it's available. And so here we started. And then we can just connect our client and do the usual thing. At the end, we remove the client and we remove the container as well. And it's just exactly the same Docker Compose file from our start. So there are no changes here. So when I run this, will this work or will this not work? Hopefully it works. Let's see. As always, this will take like 20 seconds or so to start up. But while we're doing that, we can look at what is actually happening on the container side. And this one is unfortunately a bit hard to read. But you can see multiple things running at the same time here. So you can see we have multiple containers. We have a Socket container. We'll get into Socket in a moment. We have our Elasticsearch container that is running. That's good. We have Docker Compose because, well, we started Docker Compose, so we need a Compose container to actually start Docker Compose. And we have this other thing here called Ryak. So in total, we have 4 containers running now, even though we only need 1. So what are all these containers that we have running? And by the way, hopefully our tests have, our tests finished in the background. So this worked all nicely. But what are all those 4 containers that we have? So we need Elasticsearch because we're testing against that. That's obvious. We need the Docker Compose container because we're starting a Docker Compose file. And the Docker Compose container is which is running that Docker Compose file. So that makes also sense. What is Socket and what is Ryak? So the Socket is from the socket cat. It's basically like a Linux utility to actually talk to the Docker daemon. And this is only added on Mac because Mac doesn't have a good API to talk to your Docker containers from within your Java application. It basically exposes on the network the API of the Docker daemon, and you can then run commands against that. So that's why this is working here. And you only need that if you're using Docker Compose. If you use a container itself, you don't need to talk to the Docker daemon much, and then you don't need that dependency. The other thing is you have Ryak. Ryak is there just for cleanup. So Ryak is a comic character. Like this is what one of the ways Ryak might look like. And Ryak can basically drop a death note if it knows your name. So the idea is you start this Ryak thing, Ryak knows these are all the Docker containers that you have started for this test, and at the very end, Ryak will make sure everything that has been started by this test will be cleaned up as well. So there is nothing that can remain. It will automatically clean up your processes, and no Docker containers remain. That's the entire idea of that. So the nice thing is, this ties into your IDE. You can customize your lifecycle. You can start as many instances as you want. You can customize the Docker image. You can customize the version. It's a slightly hacky configuration because you need the Docker Compose file. And maybe you don't want to have a Docker Compose file around. So for that, you could also have a custom integration into test containers. And we have one of those. So for example, if you go to searchmaven.org, you can see these are all the test containers that are being provided. And you can see there's Elasticsearch, there's also lots of other databases. So you can see Kafka and MariaDB, and there is even Oracle and SQL Server. There are lots of images you can use and just run with them. So for Elasticsearch, we have an Elasticsearch container, which is also in the documentation, and you can simply run that. And what that looks like is pretty much what you would expect. So heading over to this one here. So what we do here is we fetch the version number. This is just like before. This is nothing new. The new thing is this one here. We have a new Elasticsearch container where we basically say, this is the image that we want to run, and then we just add the version. We start the container, and at the end, we just say like, okay, this is where this is running. I extract that into a final variable, so I can use that in my client. I set up my client to connect to that. And at the very end, I close both my client and I shut down the container as well. If I run that, will this work? Hopefully, yes. Let's see. Again, obviously this will take 20 seconds because Java process in a container will just take that long. You can see test containers also has like some slight syntactic sugar around that because it checks like your Docker version and how much disk space you have available, but that's all fine. Let's see what we have on the Docker PS side. So here you can see we have Elasticsearch running and we have RAIC running. So RAIC is just there for the cleanup. And this keeps running. You can see we have still Elasticsearch running up for 28 seconds and 29 for RAIC. Our tests are, it's about to come up. Okay, our tests are running now. This worked. And you can see right now it's only RAIC that is left. So Elasticsearch has been shut down automatically. RAIC is still hanging around for a little longer, and RAIC was just waiting and would have removed anything that would have been left from our tests, so that all leftovers are cleaned up. So RAIC is normally hanging around for a few more seconds, but now you can see it's already gone because there was nothing else to clean up, and RAIC shut itself down again. That's all there is to that. Other languages. So test containers is trying to be a bit of a broader approach to support more languages. So the Scala and the Go support is reasonably good. You can actually use those already. For other programming languages, it's much earlier. So for example, .NET, Python, JavaScript, and Rust. Somebody started a project, but I'm not sure, like they're either very early alpha or they're not functional yet at all. But the idea is to have like more of a structured approach that you just start containers for your integration tests and shut them down at the end. And the idea of the project is you have the version for Java and you just bring that to other projects then. That's the overall idea. You can, by the way, also use this to run UI tests. So what you do is you start Selenium or WebDriver and you run your tests against the container with that. And you can then, for example, define that only if the test fails, I want to save the screen recording, and then you just have the screen recording of the failed tests, and you can look into them to see what has actually failed in that integration test or the UI test that you have been running. So that is supported by test containers as well, and makes your life maybe much easier around that. It's good because it supports your IDE. You can customize the lifecycle, you can customize the image. You just need that custom integration, though you don't really need it because you could just do the same thing with the generic test containers and then just say like, hey, this will expose something on port 9200. Wait until this container has come up and responds with HTTP on port 9200, and you wouldn't need a custom integration at all anymore. So that should be pretty stable and you don't have many external dependencies. What happens if you try to run Docker on top of Docker? Because that might make your testing much more interesting. So it's called Dockering Docker, or you can run it as a sidecar. And the general idea is that you will need from within your container, you will want to probably spawn another container on the outside to do the actual testing. So what this is doing, and you will need to run this from the right directory to actually make everything available that we do is. So we take our Java program, and I'm running my Java program in a Maven 3 container. And then I run Maven, and I run test at the very end, and I make sure I build my parent project, which contains the tests, and I run my test containers custom. And how to actually create the Elasticsearch instance from within my container is that I actually mount the socket, the Docker socket, into the container, so I can start another Docker socket on the outside, or another Docker image on the outside. So my Maven 3 container will next to it start an Elasticsearch instance as another container, and test containers will automatically figure out how to connect to them. And that's really all there is to make that run just on Docker. So you wouldn't need to have Java installed locally to compile it. You could just run it all from within Docker. So let's say, no, I need Docker. And I need Docker. Okay, I think I'll need to cheat because nobody wants to see me type that. Let's see if it remembers. I remember, cool. So we have Docker run, we run a container, we mount the local directory. I'm in the wrong directory, so I'll need to change directory. And then we just compile that and start various things. But what we need to do is first, we need to move to the parent again. Oh no, now I lost my command. This is not what I wanted. Why did I lose you? Let me cheat. The actual command that I need is here, because nobody wants to see me type that much, and I'll probably mistype. So this should work now. What will happen now? We wait. Yes, exactly. That's pretty much the point. No, sorry? Yeah, that. That is true, thank you. There was a line break. Without the line break, I'm not building much here. And now I'm missing a space. Let's fix the space, and then we're off. So now we actually run something. So we run Maven with our parent and the actual test project. We run the test phase, and we mount the Docker socket to actually make that run. And now it's downloading half the internet because, well, we don't have any dependencies in there because it's a fresh container, and this will just take some time. How many containers will be running in parallel here now? So right now, I only have Maven 3 because it's still fetching my dependencies. And that is ongoing. So it will take some more time. You can see this is just from the parent still. We're still building the parent, and after the parent will compile my other project. And once we have all the Maven dependencies of that, only then will we be able to actually start doing something. So you can actually see then how many dependencies you have in your project. And I hope my internet is reasonably good here, because otherwise it will take quite a while to start it up. We don't have to finish this. This is just more for the general idea. This gives you a super clean starting point, because you don't have any external dependencies or anything, but it will take a long time. How could I speed up this process? You could just mount an external volume where you have your dependencies. So whenever you start up the Maven container, it's clean, but it has a pointer to where the Maven dependencies live, and it doesn't have to re-download them on every test run. You just need to create that mount point, and then you can just reuse that. And we're still in the phase of downloading all the dependencies. Hopefully we'll be getting there. Let's see how our containers are doing. You can see we still only have one Maven 3 container that is up for about a minute. I think it will take at least 2 minutes normally to actually get all the dependencies. So we're still in the progress phase. Keep downloading dependencies. This might take a while because this is not super fast. Let's see, how fast are you? 100K is not super fast. This will take a while. Let's see. We still have 4 minutes left. I'm curious if we will make that. Sync queries. Come on, you can do that. By the way, any questions in the meantime while we wait for this to finish? Because we're getting pretty close to the end. Any questions so far? No questions? Okay, good. Then we'll see how we are progressing here. I hope I'm getting all the dependencies in due time. Let's see. Or let me continue with my slides, and we'll come back to the final process at the end. So I hope we've cleaned up why integration tests, and that unit tests are not enough, and why you want to have tests in general. If we disagree on that, we can discuss afterwards. Probably why not mocking, why in-memory tests might not be enough, and why the actual data store is also a pain to test, because we will always need to keep the version in sync, and you always need to make sure that external thing is running. We've looked a bit at, like, if you want to run an embedded version, how you could do that. If you want to include it in your build tools, that's mostly if you're very much a Java programmer and like your POMs. That's a very nice approach. Otherwise, I think test containers are a very nice solution to actually integrate that into your Java program. If you want to try all of that out, I have the demo code. It's not much, but just as a starting point, it's all on GitHub. You can just go there, pull down the code, and get the latest version. That's probably, if you want to take one picture of this talk, this is the one that makes most sense, I guess, because then you can just play around with it. And I think we have like 2 minutes left. Let's check. we are still downloading dependencies. Okay. The internet is not quick enough to make this work. Depending on the time you have, sometimes it only takes like 2 minutes. Now it has been running for 4 minutes already. So I guess the internet is just slightly too slow to make this work. But you can see this is super clean and works. It just takes forever if your internet is not good. So that's why you probably don't want to do that with a clean installation every time. Okay, I have a couple of stickers up front. If anybody wants stickers, grab the stickers. Are there any questions now? And while you can think about the questions, I'll just let this run here and we'll see if it finishes or not. Because we have like 2 minutes left, but probably we have too many dependencies. Even though it's just a simple project. So, any questions?
We can use MongoDB to that.
Yeah, so Flapdoodle has MongoDB. Let me quickly show you.
I can see Mongo in your screen.
Sorry, in test containers or in Flapdoodle or where? So Flapdoodle has it and test containers has it as well. So this would be the one for the embedded version. I've used that in the past. This is working. I've used it for a couple of years. So this will just download the binaries to your instance and then just run the binary. Or test containers has also test containers, MongoDB. Should have that as well.
Oh, good.
Yeah, this is just an example project, but yeah. It does do test containers, so you have it either here in Flapdoodle where you can run in embedded, which would look something like this, where you just say Mongo start default instance, and in test containers, yeah, you can just define the data source and then you can start it up.
Okay, thanks. And second question, my developers use sorry,
No worries.
no words.
Unfortunately, my Russian is not very good.
Who next?
Hello, thanks for the presentation. So, do you use parallel execution with test containers or not?
So in this example, I don't.
No, on your project. I mean.
In our project?
Yeah.
I mean, since we are building Elasticsearch itself, our test procedures are very different because we want to test Elasticsearch itself and not the program around it. So we don't really run test containers ourselves. We have done the test containers integration. We heavily parallelize our tests, but actually our own tests are all based on Gradle. And what we do is, from within Gradle, we start Elasticsearch instances up and down to test them. But internally at Elastic, we don't use test containers because we don't want to test the integration into Elasticsearch, but we need to test Elasticsearch itself. So for that one, I cannot tell you what we do because we don't use it like that. Probably since the test containers for Elasticsearch, because of the Java process, take like 20 seconds to start up, I would assume you would want to run as few instances as possible. So you will run at least 4 class, so at most 1 instance per class, if not shared more widely. What you can do is you can just create 1 static instance in kind of like the abstract class where you set up your entire tests and then reuse them throughout your entire tests. You could start 1 instance for each class, but it would be very slow because you will need to start it up, like the 20 seconds will happen for every test class. And it might prolong your build times to, I don't know, you'll probably add, I don't know how many minutes, but quite a few depending on the number of classes you have. So I would be careful. Yes, you can do it to have a cleaner state, but probably there's not too much point in starting too many instances. And running it in parallel will just be a question of how many resources do your instances or do your computers have?
Do you use any orchestration tool like Kubernetes to start on, for example, Elasticsearch on multiple nodes to run your tests in parallel?
For a test environment, no. So what we have is we have a Helm chart right now, and probably there will be an operator in the future as well. So we do have integrations into that, but not for testing. Also, I think it would be too heavy for testing. And this is really more like a development environment, a QA environment, and not something you would run locally. So everything I've shown here is kind of like, this is what you run locally to test. But maybe you have like a development environment, and there you could provision your entire environment with Kubernetes.
We don't have yet, but we are considering to.
Yeah, I don't think you will want to run a full Kubernetes setup because it will be even more complex and heavy on a local instance. But you might have like, if you have one central development environment, that's where that might come into place, yes.
Last question. So you use Gradle. Is it a Docker Gradle plugin for starting containers, or you use something else?
To create our Docker images?
Yeah. To create containers.
Yeah, so from what I know, no, we don't use that. We have a very specific Gradle setup. Like we have 2 full-time Gradle engineers. Basically, we hired somebody from Gradleware to do that. We build everything ourselves, also because our build jobs are super complicated. Like the Gradle job that builds Elasticsearch also builds the Windows binaries, the Debian packages, the RPM packages, the Docker images. It's not just like throwing in a random plugin and doing that, but it's a much more complicated process than doing that. I don't think it's anything you would want to do in your own project. We just have a bit of a different need, and like the binaries we build need to be widely available, and they will be pushed to the Docker registry automatically, and there are more things, and we will publish the Debian and tar.gz and everything automatically. So it just works a bit differently than what you would do in most other projects. I don't think it will really apply to like a regular project for that.
Thanks.
Sure. I think we're pretty much out of time. Internet is too slow. This is still building. You know why you shouldn't do that. I think this has been running for 5 minutes or more now. Yeah, 11 minutes. This is not going to happen today. Thanks a lot.
Thanks, guys. Thanks, Philipp. Guys, we have a small break for 10 minutes, and after that we will have Michael Aronson, platform architect from AppFlyer, telling about testing environments. So please be here in 10 minutes.